Best case, worst case, and average case of an algorithm. We will take one example of sequential search. Sequential search is nothing but an array is given and key is given. We have to find a particular key element in a given array. If key element is present in array, we are going to return its index. Otherwise, we are going to return -1 to show that element is not present in array. So algorithm looks like this. For I equals to 0 to n minus 1, sequential search takes 0 to n minus 1 elements, that are n elements under the name A, and key k. So this is array, index are ranging from 0 to n minus 1, and k is the key. Now, for I equals to 0, that is index is starting from 0 and going up to n minus 1. We are comparing with key an element at I, that is A of I is equals to key. If key element matches with array element, we are returning an index. If key element is not matching with element, then we are going back to again follow, incrementing I, again comparing, and so on. What will happen if this for loop terminates? If for loop terminates, control returns to return statement. That means if for loop is being traversed and no matching of key element is being found, we are returning -1 to show that no element is present in a given array list. If element is found at any particular location, then its location with this return statement would be returned. So this is our simple algorithm of sequential search. Now, we will look into worst case complexity. Now, worst case is the time complexity when algorithm runs for the longest time. That means in this algorithm, key element is searched from the list of n elements for the longest time. That means we will compare each element one by another, and after traversing or comparing the last element also, we are not even able to find a key, and we will return -1. So in this case, key is 45 and array is having elements like 10, 50, 30, 40, 20. And this key element we'll compare with first 10. It is not matching. 50 not matching, 30 not matching, 40 not matching, 20 not matching. Then we are returning what? We are returning -1. So we have taken how many steps? 1 comparison, 2 comparison, 3 comparison, 4th comparison, 5th comparison, and the last 6th statement is return. So this is the worst case. Worst case is defined as the longest number or maximum number of steps that is being taken by algorithm. So it is nothing but worst case of an input size n is for which algorithm runs the longest. That is my algorithm. So how many steps in a worst case for possible size of n inputs? If we are considering here, we are considering 5 elements. So how many comparisons are done in a worst case? 5 comparison. First comparing with element at 0, second comparison at element 1, third comparison at element 2, fourth comparison, and fifth comparison. Now consider this is n, right? So there are n elements. So how many comparisons will be there? N comparison. That's why complexity in worst case of sequential search is n. That means maximum how many comparisons will be done? N comparisons will be done. So C worst of n is equals to n. Now, what is best case efficiency of sequential search? So best case is when input or key is found at first possible location. That means for which algorithm runs the fastest or with the minimum number of steps, I can say. So and again algorithm is same for I equal to 0 to n minus 1. If element at a of I is matched with k, then return I. If not that case, if formula terminates, then return -1. But in this case, key is 10 and we have to search this key in array list A. So what we'll do, we will first compare this 10 with the very first element at index 0. Yo, match fine. That's why we will return value of I, which is equals to 0. And algorithm terminates. If return statement is being executed, no any other execute statements will be executed further. So in how many steps we have got an answer? We have got an answer in a best case of sequential search in only one step. That's why complexity at best case of n in sequential search is equals to n. Now, average case. Average case complexity is not easy to find it out. Here we have to randomly pick some of the inputs. For example, in best case, we are considering that element is matching at first location. Worst case, we are checking or taking key element which is not present in our list. So in average case, we are taking random inputs. These random inputs might be present anywhere in array or might not be present in array. So to analyze algorithm's average case efficiency, we need something else that is nothing but we need to make some assumption. What are these assumption? Assumption is first that let the probability of being successful search is P. So probability of being successful search is P and probability of being unsuccessful search is 1 minus P obviously. And since this is a random input and we have to be very fair, so we are making that probability of matching first element at ith position is same. That means there are fair chance of each position so that it can match with key. Now successful search is having P and unsuccessful search we have probability 1 minus P. Okay. Now n is total number of elements in array list. P is probability of successful search in a list. Therefore, 1 minus P is probability of getting unsuccessful search. Average complexity over n elements is probability of successful search plus probability of unsuccessful search. Now, for very first element, probability of successful search is out of n element is equals to P by n. For second element, it is 2P by n. For third element, it is 3P by n. For fourth element, it is 4P by n and so on. So average complexity of n variable is first element's probability plus second and plus probability of unsuccessful search. For n element, it is same 1 minus P. But successful search of each element is different. So p by n plus 2p by n plus 3p by n up to np by n. Let us take p of by n common and 1 plus 2 plus 3. So summation from 1 to n is denoted by n into n plus 1 by 2 plus n into 1 minus p. N cancel. Therefore, one summation formula from 1 to n I equal to 1 to n. Summation of I is denoted as n into n plus 1 by 2. That is a substitution we have made over here in above formula. So p into n plus 1 by 2 plus n into 1 minus p. This is the complexity of sequential search in average case over n inputs. For any random number, we will make use of this formula. Okay, so in today's lecture, we have seen thank you everyone for being with lecture. Thank you.